So this question doesn't quite fit very well in the end of the lecture, but it's in the section, so we must go over it. This is going to be an interest rate problem, and we're always going to be compounded annually. So basically with these problems in this section, you kind of just have to plug stuff in. The amount of money A, so A is going to be the amount of money that a principal P, because P is my principal, this is my initial amount, okay, will be worth after T years. T represents time, and in this case we're measuring in years, at an interest rate R. So there's my interest rate, and we always want your interest rate in decimal form. Okay, now that I've defined those variables, I can get rid of that whole sentence that is all kind of wordy and jumbly. Okay, I know it's compounded annually. That's great news. Is given by this. A equals P times 1 plus R to the T. This is an exponential function. That's why this is in this section. So now I have my equation or my formula, and I have what my variables are. A is going to be the amount of money. So if you're asking for the amount after 5 years, the amount after 10 years, etc. So now I'm getting into the root of the question. Here's my definition and here's my question. Suppose that $20,000 is invested. That means your principal amount, P, equals $20,000. Because it's invested, that means that it's the initial amount. It's invested at a 4% interest rate. Well, my rate is R, but I want my rate in decimal form. So 4% in decimal form is 0.04. There's my interest rate. Compounded annually, we already know that because that's what we have defined the problem as. Okay, A says, find the function for the amount in the account after T years. So I want to know how much money is going to be in the account after T years, and I'm finding a function. In order for it to be a function, there must be an input variable and an output variable, meaning there will be two variables remaining. So let's plug this in. I have A equals P times 1 plus R to the T. I have a P value and an R value, so let's plug those in. A equals 20,000 times 1 plus R, 0.04, to the exponent of T. I can simplify that in the parentheses to be 20,000 times 1.04 to the T. Is it true that I have two variables? Yes, I have my input variable, which is time T, and my output variable, which is the amount A. Therefore, this is my function. Part B is asking, find the amount of money in the account at T equals 0 and T equals 10. All I do is I simply plug it in, right? So T equals 0. For the first one, they're asking T equals 0. The second one, they're asking T equals 10. So let's do T equals 0 first. The biggest issue that I see in these problems is that people don't abide by the order of operations. So don't forget order of operations. I have my amount equals 20,000 times 1.04 to the T. In this case, T is 0. Anytime I have an exponent of 0, I'm going to be equaling 1. But the important thing to remember is, what is